Okay, so here I have a problem where I have a whole number. Now we could change the whole number into a fraction. That's just a little bit extra work. Because there's no fraction part with this, I'm gonna pull this out and add it at the very end once I have my mixed number. That's just gonna save me some time between multiplying this to get the LCD, an equivalent fraction. It's just gonna save me some time. So I'm going to remove this out and add in later, which I'm allowed to do. When you add, order doesn't matter. So I can wait to add this until the very end. So basically what my problem is now is 2 4/5 plus 1 1/2. And again, let me get an estimation for this part here, because this is the part where I'm doing a lot of math, a lot of steps, and I could make a mistake. 1/2 will round my 1 up to a 2. And 4/5 is greater than 1/2, so this will round up to a 3. So 3 plus 2, my answer here should be around 5. Okay, so first I want to change my mixed numbers to improper fractions. 5 times 2 is 10, plus 4 is 14 over 5. Our denominator stays the same. 2 times 1 is 2, plus 1 is 3. So these are relatively small numbers, and if I look at the list method, using 5 as the number that I list out the multiples of, 5 is my first multiple, 5 times 2 is 10, that is the least common denominator. So I want to rewrite each fraction with the least common denominator, so I can add them. So the relationship between 2 and 10 is a factor of 5. To get to 10 from 2, we multiply by 5. So since I multiply my denominator by 5, I multiply my numerator by 5. So 15 over 10 is the same as 3/2. The relationship between 5 and 10 is a factor of 2. So to get to 10 from 5, I multiply by 2. Then I multiply my numerator by 2 as well. 28 over 10. So now that I have equivalent fractions, I can go ahead and add my fractions. 28 plus 15. So I'll do this over here. 8 plus 5 is 13. Carry the 1. 2 plus 2 is 4. So 43 over 10 is my answer from adding these two mixed numbers. So now I'm going to change this back into a mixed number, and once I have that mixed number, I can add my 5 to the whole number part, because there's no fraction part here. I didn't need to involve this number here, my 5, my whole number, in the rest of the problem. So to change 43/10 into a mixed number, I take 10 and divide it into 43. And 10 goes into 43 4 times. So my quotient is going to become my whole number. 4 times 10 is 40. And when I subtract, my remainder is 3. So 43/10 is equal to 4 and 3/10. Now, this is in the same ballpark as 5. If I were to estimate my final answer to the nearest whole number, it would be 4. But it's still close to 5. 4 is close enough to 5 that I don't feel like I've made any major errors. If I came up with an answer of 14 or 40 or 1 or 2, then I would go back and check my work. But when we're estimating using fractions, this is really within ballpark. 4 and 3/10 is close enough to 5. Okay, so now I'm going to go back. I have my 4 and 3/10, and I'm going to add 5 to it. So 9 and 3/10 is going to be my final answer. Now, if you choose to make this a fraction by putting 5/1 and then making it an equivalent fraction, still least common denominator would be 10, so 50/10, and adding it in as you add the other fractions, that's perfectly acceptable. One of the beautiful things about math is there are many different ways to approach a problem, and as long as you're following the rules, as long as you're mathematically correct and not careless and keeping track of your work, at the end, as long as your answer is correct, then that tells you that you've done it the right way. Okay, now let's look at a subtraction problem. Okay, so again, what we're going to do is change our mixed number into an improper fraction. So I'm going to multiply 14 by 7. I'll do this over here. 14 times 7, 7 times 4 is 28. 7 times 1 is 7 plus 2 is 98. And then 98 plus 3 is 101. Okay, and then here we have 7 times 3, which is 21, plus 6 is 27. Okay, now we look at these denominators, 14 and 7, and we can tell by inspection that 14 is going to be our least common denominator. It's the smallest number that both of these go into. So I'm going to rewrite and here my fraction doesn't change because to get to 14 from 14 we just multiply by 1. But here to get to 14 from 7 we've got to multiply by 2. So 2 times 27 is 54. So now that we have the same denominator, we can go ahead and do our subtraction. So I'm going to do that subtraction over here. My 1 needs to borrow a 1 from my 10, so 4 from 11 is 7, and 5 from 9 is 4. And I'm going to check my answer, 47 plus 54, 7 and 4 is 11, and then 101, so that answer is correct. So I end up with 47/14. Then what I need to do is change that into a mixed number by dividing my denominator into my numerator. So 14 into 47, let's see. What's 3 times 14? 3 times 14 is 42. Okay, so 3 is my quotient, which is my whole number. 5 is my remainder, which is my new numerator, and my denominator stays the same, and I cannot reduce this. So this is going to be my final answer. Now I want to go back and ask myself if this makes sense. I didn't estimate an answer at the beginning, so now I'm going to go back and say, does this answer make sense? If I were to estimate to the nearest whole number for this mixed number, 3/14 is less than a half, so this would estimate as 7. And 6/7 is greater than a half, so this would estimate as 1 higher than 3, which would be 4. So 7 minus 4 is 3, and this answer is close to 3 in the same ballpark. So I feel good about my answer that it makes sense.